Hello everyone. So today's problem is flow over a circular cylinder, and we need to solve this problem using ANSYS CFX. So the problem states that there is a cylinder of diameter 0.02 millimeter and it is surrounded by a rectangle domain where this is inlet, this is outlet, and these green two lines are the top and bottom surface. So from inlet to the first point of the circle, the distance is L infinity, and from this point to the outlet, this distance is LO, and the values of L infinity and LO is given to you. Also, the height of the rectangle is given to you, which is 10 times B. So I'll show you step by step, starting from creating the geometry, then mesh, then setup, solution, and finally the result. So let's get started. So we'll start from ANSYS workbench. This is the new window, and we want to drag fluid flow CFX onto the project schematic. So for the given problem, these are the steps we need to follow to get the full results, where the first point is create the geometry in Design Modular. So let's start with the creating geometry in Design Modular. Because it says we need to create geometry in Design Modular, so right click on geometry, then select new Design Modular geometry. Okay, so we get the new window of Design Modular. First step is to check the units, if it's in meter or not, because all the dimensions in the given problem is given in meters. Then let's select it to Z to make it 2D in XY plane. Select sketching, starting with settings. Click on grid and snap, and change it to 1 meter for major grid and minor grid. Then click on draw. Let's start with circle. So click on circle. When you move the cursor close to the origin, you should see P, and that time draw the circle. Let's draw a rectangle around the circle. Alright. Then click on dimensions. Let's start with the diameter of the circle. So I select diameter. In the problem, the diameter of the circle is given to 0.2 meter. So let's change this diameter to 0.2 meter and hit enter. Now zoom in here, and we should see the circle. Next, we want to select the dimensions of the rectangle domain around the circle. So let's first calculate from the given problem. So because this is a circle, so A and B will be equal, which is 0.2 millimeter. Then L infinity is given in the problem as 5A, so in our case it should be 1 meter. LO, which is given as 10A, this time it should be 2 meter, and H, which is given in the problem as 10 times B, so for our case it should be 2 meter. So let's create this domain for our case. Alright, so let's select horizontal dimension, and then select this circle 1 times, and then we are looking for one vertex of the rectangle. Once we get it, select this one. So this should be our L infinity, which is in our case 1 meter. So enter 1 meter and hit enter. Next, similar way, select the circle again, and looking for another vertex on right hand side. So, and this H3 should be 2 meter in our case. Now because the cylinder is vertically centered, so when we select the vertical dimension, we should select the center of the circle, and then let's click on the top vertex of the rectangle, and this should be 1 meter, which is half of h. Enter. And we also calculated that h for this case is 2 meters, so just click first top vertex and bottom vertex, and this should be 2 meters. Alright, so we created this geometry. Let's fit to this window, then click on modeling, expand XY plane. So this is our sketch. You can hide this dimension. Even though this is a 2D problem, but still CFX doesn't allow us to run 2D, so we want to make it quasi 2D model. So let's click on extrude. For the geometry, let's select the sketch one that we just created, hit apply. For direction vector, click XY plane. So we want the extrude should occur on Z direction. That's why we hit XY plane, apply, and the direction should be normal to the XY plane, so keep it as it is. So the thickness of the model, let's consider 3 mm, which would be 0.003, and then hit generate. So this is our model with the thickness of 3 mm. Once it's done, hit save, and that's how we create geometry for this problem.